Hello everyone. I, Nilesh Kumar Sen, working as an assistant professor at Computer Science Engineering AIML department of ABES Engineering College, Ghaziabad. In this video series, I'm going to discuss about operating system unit 4. That is all about memory management. Here are the terms that we are going to cover in this series, and in the coming minutes, we are going to discuss brief about each and every topics and its subtopics. So the very first topic would be introduction to memory management. What is memory management? What its importance? What are the goals? And most important topic from this very video would be basic bare machine and resident monitor. In the latter part, we are going to cover introduction to multiprogramming. What is the purpose of multiprogramming? What are its importance in maximizing CPU utilization and system throughput so that system or CPU would be busy. Later, we'll cover on fixed partitioning in operating systems. In this series, we are going to cover explanation of fixed partitioning concepts, comparison with dynamic partitioning and other techniques, advantages and disadvantages of fixed partitioning, equal size partitions. In this, we are going to cover memory allocation algorithms. We are also going to discuss few numericals based on first fit, best fit, worst fit, and next fit. And in this, we are also going to cover memory layout with equal size partitions. Later, we will discuss about unequal size partitions, such as flexibility, adaptability compared to equal size partitions, and allocation strategies we are also going to cover. Later, we are going to cover in fragmentation in fixed partitions. What is fragmentations? What are its types? What are the causes and consequences of fragmentation and fixed partitioning, impact on the systems, and also on the resource utilization? What later we'll cover in depth about fragmentations, internal fragmentations, and techniques, compactions, external fragmentations, its techniques, allocation, deallocation strategies, and fragmentations measurement and analysis. In this, we are going to calculate quantifying fragmentations, fragmentation ratios, and we are also going to learn about tools and techniques for analyzing fragmentation and operating systems, interpretation of fragmentation metrics and their implications. And lastly, we are going to cover optimization techniques such as body systems, slab allocations, fragmentation aware scheduling policies, adaptive memory management strategies on workload characteristics. So all those content will be covered in the second and third videos. Later, we are going to cover multiprogramming with fixed partitions. So in this very series, we are going to learn about what is multiprogramming with fixed partitions, what are its types, partition allocation methods such as static and dynamic, its descriptions, advantages, and implementations of both. Further, we are going to cover memory management techniques. Those are overlays and swapping. We'll discuss in detail about its concepts and implementations too. Later, we are going to move forward with variable partitioning. So in this, we are going to learn about its definitions, concepts, partition allocation methods, using variable partitions, its advantages and disadvantages over fixed partitioning, its implementations, buddy systems, advantages and disadvantages, and slab allocations, along with advantages and disadvantages. Later in this tutorial series, we are going to learn about important topics, that is protection schemes and memory management. What are protection schemes? Its importance in OS. What are different levels at which one requires protections, such as user mode, kernel mode, supervisor mode? What are their roles in memory protections? What are its limitations, privileges? Later, we'll cover hardware support for memory protection. In this very series, we are going to learn about memory management units. TLB, one of the most important topic, translation local site buffer, its functionality, impact on memory protections, segmentations with memory management units, supports, its concepts, phasing, its concepts and implementations. And lastly, we are going to cover phased segmentation. In this, we are going to combine phasing and segmentation, and we will learn how that combination will work, what would be the concepts, how they are going to be integrated, what are phase tables for segments and segment replacement policies, uh, versus phase replacement policies, LRU for segments, and many more replacement policies for segmentations. Combining segmentation and phasing, what would be the challenges and trade-offs, its implementations, considerations, performance criteria, overhead phased segmentations, efficiency of phasing and efficiency of segmentations differences, real world applications and examples on protection schemes. Lastly, we are going to cover in this series is virtual memory, one of the most important topic from this very unit. And we are going to cover entire concepts of virtual memory, what are its importance in modern computing, phase tables and address translations in virtual memory, translations of logical address to physical addresses, what are demand phasing, how demand phasing works, what are lazy loadings on pages, and page fault handling along with numericals. Page replacement policies such as FIFO, LRU, optimal page replacement, and clock page replacement. We are going to cover along with numericals. Later, we are going to discuss about thrashing. What is thrashing? What are its causes and symptoms? Prevention techniques for thrashing. Advantages and disadvantages of virtual memories. What are its limitations and drawbacks? And from this very unit, one more important topic is cache memory organization. So in this particular series, we are going to discuss about what is cache memory, what are its importance in computer system, what cache hierarchy, what are different labels at cache allocated, L1, L2, L3, what are cache write policies, what are cache performance policies, and last, that is locality of reference. In this very series, we are going to discuss about locality of references and its types. Mainly, we are going to cover temporal locality and spatial locality. I will try to cover as much as deeper in the topics and its subtopics, along with numericals, along with implementations, as and when required.